Okay, let's continue the discussion. We study section 7.8. Phase shift. Sine curve fitting. Sinusoidal curve fitting. Okay, so we already know that when we have y is equal to a times sine kx, then this 2 pi over k is the period. Absolute value of a is the amplitude. Okay, so this is something we already know. And in this section 7.8, we are going to graph a sine omega x minus phi plus b. Okay, so we're going to graph this function. This function, so we first start from the case without b. So first, let b equal to 0. When b is equal to 0, we have y equal to a sine omega x minus phi. And we factor out omega, we get factor out omega, so we get x minus phi over omega, then quantity times omega. Okay. And remember that sine and cosine, sine is an odd function, cosine is an even function. So if you have a negative omega, for example, if you have a sine negative 2x, you can apply the other property, move negative sign forward to get a sine 2x. So you can make some algebraic manipulation so that you move the negative sign forward. So because of this property, we always, if this omega has negative sign, we always move it forward so that the omega is always positive. So here we assume omega positive. Okay, so we don't handle the negative omega. A negative omega, you just move that negative sign forward. Okay, so let's check. You know that we know sine 0 is 0. Sine 0 is 0. And this time, if we want this omega x minus phi over omega equal to 0, this input, the whole thing, this complex stuff is input. If the input is equal to 0, you solve it, you get x has to be, omega is now 0, so x minus phi over omega is 0. So x is phi over omega. X is phi over omega. Okay, so this phi over omega is called the phase shift. Of the function y is equal to a sine omega x minus phi. Okay, so this phi over omega is called the phase shift. So in the expression a sine omega x minus phi, so the definition for y equal to a sine omega x minus phi. We have three concepts. Amplitude, opposite value of a. Remember, you move this, possibly you move negative sign forward, so this a can be positive, negative. So we just take the opposite value, it's called amplitude. And period is equal to t, because t is 2 pi over omega. So here omega is positive, so this number is a positive number. And the phase shift is equal to this phi over omega. Okay, so that's a three concept: amplitude, period, and the phase shift. Okay, and from the graph shifting theory, we have some idea. If this phi is positive, phi is positive, phi of omega is positive, minus a positive number, the graph is the graph is shift to the right. For positive omega, you shift to the right. Phi, for positive phi. If phi is negative, phi over omega becomes negative. Your phase shift is negative, the graph is shifted to the left. Okay? Left, negative. You see negative, move to negative. Positive, move to positive. Okay? Negative phi, move to negative. Positive phi, move to positive. Okay? So that's the way. Okay, let's check the example. Assume we have this function y is equal to 3 sine 2x minus pi. 3 sine 2x minus pi. And we're going to graph it. Before we graph it, the amplitude is opposite value of 3 is equal to 3. The period is 2 pi over the coefficient. Coefficient is 2, so 2 pi over 2 is pi. The phase shift is phi over omega, is pi over 2. Be careful, it's always subtraction. If it's addition, you have to write minus minus. Okay, so this is a 3 quantity. The amplitude, period, and the shift. Okay, so how do we do it? We first draw the original sine function. Just draw one period, and the other part you just repeat. Okay, so that's a sine. And you apply the period. Period becomes pi, so you just replace this 2 pi by pi. Sorry, that's bad. Not here. Here. Replace 2 pi by pi. And this midpoint is pi over 2. It's always half. Here's 2 pi, this is pi. Here's pi, this is pi over 2. Okay. Okay. See? So this is sine 2x. This is 1, this is negative 1. So the same one, the 1 and negative 1. And third, you have this shift. Phase shift is pi over 2. So it means instead of starting the graph from 0, you're going to start the graph from pi over 2. Because it's positive, so move to the right. Move to the positive. So you start from pi over 2. This is pi. This is a 3 pi over 2. Okay, so this becomes a sine 2x minus pi. This is sine 2x minus pi over 2. The same thing. This is the place you get this pi over 2. Okay, so same thing here. It's a 1 and negative 1. So first, you have the original sine function. And second, you apply the period to shrink the period interval. Here is a 0 to pi, the original period 2 pi. Now it's a 0 pi. The period becomes from 0 to pi. You just change this 2 pi to be pi, and divided by 2 is the middle point. And then you get the shift. Shift is pi over 2. It means you do not start from 0, 0. You start from pi over 2. You repeat this graph. So start from pi over 2, repeat it. That's what we mean. We shift it to the right. And then we handle this amplitude. Amplitude means you're going to stretch it along the y direction. So you still have this pi over 2, pi, 3 pi over 2, pi over 2, pi, 3 pi over 2. You're going to make it bigger. Yeah. Pi over 2, pi, 3 pi over 2. And this is 3. Well, this is negative 3. Okay, so that's the graph. Okay, you see what is the order for us to do the graph? We do the period first, and the phase shift second, and this amplitude third. Period, phase shift, amplitude. Okay, so that's how we graph it. That's how we graph it. Okay, so this is a one way to graph a function, and let's check other ways to graph it. Okay, this is one way. Let's find the other way. The key point method. Sine function is determined by not determined. The shape of the graph is determined by the sine 0, sine pi over 2, sine pi, sine 3 pi over 2, and sine 2 pi. Okay, it is determined by those 5 values. So what I mean, it is determined by those 5 values. It's determined by here, 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 and here. You see, 1, 2, 3, 4, 5. Those 5 values. You need to figure out the value at 0, pi over 2, pi, 3 pi over 2, and 2 pi. And then you can just use this wave graph to connect them. And now we have y equal to 3 sine 2x minus pi. So how do we get it? We want the 0. So sine 2x minus pi, when this 2x minus pi is 0, because you see here the 0, sine 0. So you let 2x minus pi equal to 0, then x is pi over 2. When x is pi over 2, sine 0 is 0. Sine 0 is 0. So when x is pi over 2, y is 0. So we have first point, pi over 2 and 0. And next, you get the sine pi over 2. So 2x minus pi is pi over 2. Then x, you solve it, it's what's that? It's a 3 pi over 4. When 2x minus pi is a pi over 2, sine pi over 2 is 1. Y is equal to 3. So this time, this is 0, 1, 0, negative 1, 0. So for the second value, you get a 1. 3 times 1 is 3. So you get 3 pi over 4 and 3. And similarly, just repeat. You let 2x minus pi equal to pi. 2x minus pi equal to pi, then x is equal to pi. X is pi, the 2 pi minus pi is pi. Then in this case, you see sine pi is 0. 0 times 3 is 0. So you get pi 0. Next, 2x minus pi is 3 pi over 2. 3 pi over 2, you simplify it, it's x is equal to 5 pi over 4. X is 5 pi over 4, sine, you have this value, sine 3 pi over 2 is negative 1, times 3 is negative 3. Okay, and then you get 2 pi minus pi is, 2x minus pi is 2 pi. Then x is 3 pi over 2. 3 pi over 2. 3 pi over 2, sine 2 pi is 0, times 3 is 0. So you get 3 pi over 2, 0. Okay, so we have 5 points. To determine the sine and the cosine function, we only need 5 points. Okay, so how do we graph? Pi over 2, 0. So you get pi over 2, pi, 3 pi over 2. Okay, so pi over 2. This is pi, the 3 pi over 2. And at pi over 2, it's 0, so this is a point. At 3 pi over 4, 3 pi over 4 is the midpoint. The value is 3, so it's here. At pi, the value is 0, you get here. At 5 pi over 4, the value is negative 3. This is 5 pi over 4. It's 3 pi over 4, 5 pi over 4. At 5 pi over 4, it's negative 3. At 3 pi over 2 is positive 0. So you just use the wave function to connect it. Okay, so where was our original graph? You see? You have the more or less the same sketch. Okay, so that's the second way. The first way, you can use the graph shift to find the answer. And second, you can just use the key points. So for the key points, you get 0, 1, 0, negative 1, 0. And you solve for the equation 0 pi over 2, pi, 3 pi over 2, and 2 pi. You find the corresponding y value, and you find the corresponding x value and the y value. You determine the point, you use a wave function to graph it. Okay, so that's the second method to graph this y equal to a times sine omega x minus phi. Okay. let's check the second example. Let's check the second example. You can graph sine. You can also graph cosine. The sine cosine, there's no serious difference except the starting point. Sine starts from, you see, sine and cosine are the same thing. Sine is like this. Cosine, you actually draw the same thing, but you do not start from 0. You start from negative pi over 2. Of course, normally we extend it to consider from 0 to pi to 2 pi, but the graph is actually start from negative pi over 2 and get this. Okay, so this is a sine and cosine. Okay, so the second example. We have the y equal to 2 cosine 4x plus 3 pi and plus 1. Okay, 4x plus 3 pi and plus 1. Okay, let's see. From this, we just add a 1. We will see how do we handle this 1. This 1 does not give us any trouble. So, amplitude. Amplitude is equal to 2. Opposite value of 2 is 2. Period. Period is 2 pi over coefficient of x. It's pi over 2. The phase shift. The phase shift, you see, it's a 4x plus 3 pi. 4x plus 3 pi is equal to 4x minus negative 3 pi. So this phi is negative 3 pi over omega. So the phase shift is negative 3 pi over 4. Negative 3 pi over 4. Okay? Now let's try to sketch the graph. My sketch is so bad. Okay, this is a pi over 2. It's pi. Okay. Okay, so first the period is 2 pi divided by 4. So you will do the following thing. You divide all the numbers by 4. So you will possibly just sketch the same graph. So this part, negative pi over 2 divided by 4 is negative pi over 8. Pi over 2 divided by 4 is pi over 8. Here, divided by 4 is 3 pi over 8. This is a pi over 4. Pi is divided by 4 is pi over 4. So the new graph is cosine 4x. Here, period is divided by 4. Then all the numbers will be divided by 4. Okay, so that's the way. So we get the period correct. Once we get the period, we want the shift. Here, negative phi, negative shift to the negative part. Okay. Shift to the negative part. Shift to what? 3 pi over 4 unit. So here is negative pi over 8. Shift negative 3 pi over 4. What's this? This is a 6 over 8. So negative 7 pi over 8. Well, Negative 7 pi over 8. This is negative pi over 8. 7 pi over 8. Where is 7 pi over 8? It's a negative pi over 4. Negative 7 pi over 8. No. It's almost negative pi, so it's a okay, let me try to get this negative 7 pi over 8. Where is negative 7 pi over 8? So okay, let me get it. This is a negative pi over 4, negative pi over 2. Wow, it's big, too big. Negative negative 3 pi over 4, negative 7 pi over 8. Okay, here. Wow, it's horrible. And 0 corresponds to negative pi over 4. 0 is here. And all these numbers will be shifted to negative 3 pi over 4. So it will be like this. This point, pi over 8, pi over 8, pi over 8 minus 3 pi over 4. It's negative 5 pi over 8. Yeah, it's like this way. Okay, so you just sketch the graph here. You move it to this part. Check here. This is this point is a negative 7 pi over 8. This point, pi over 8 plus move to the negative direction is negative 5 pi over 8, and 3 pi over 8 minus 3 pi over 4 is a negative 3 pi over 8. 3 pi over 8, negative 3 pi over 8 is here. Okay, so this is the graph, and then you will repeat. Okay, so far don't stop. We don't finish it. So here we consider the period. Here we consider the phase shift, and then we're going to consider the amplitude. The amplitude is 2. So when you have this graph, let's sketch it. What do we have? We have let's make it smaller. Pi over 8, pi over 4, 3 pi over 8, pi over 2, 5 pi over 8, 6 pi over 8, and 7 pi over 8. Okay, 7 pi over 8. This is negative pi over 8, negative 2 pi over 8, negative 3 pi over 8, negative 4 pi over 8, negative 5 pi over 8, negative 6 pi over 8, negative 7 pi over 8. Okay, and amplitude is 2. So originally it's here is a 1. Here you have a 1, here you have a 2. Just make it bigger. This is 2. Okay, so originally it's 1, and you stretch it along y direction, you get a 2. So this amplitude. For this problem, there's one more number, 1. The 1 means you're going to shift it upward 1 unit. So everything will be shifted 1 unit up. We need this curve on the. So let's see. Pi, 2, 3, 4, 5, 6, 7. This is negative 7 pi over 8. So 1, 2. Originally it's here, and then you're going to lift it 1 unit. So 3. And it was 2 and now it becomes negative 1. It's like this point, these 3 points. Okay, so these 3 points lifted upward. So it's negative 1, positive 1, 2, and 3. So here's a negative 2, negative 1, 1, 2. Everything add 1, everything add 1. Okay, so that's the graph. This is a new graph, the correct graph. Y is equal to 2 times sine 4 pi plus 4x plus 3 pi n plus 1. Cosine, 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 cosine. Okay. Here is the complete proof, complete step. Surely we can use the key point to graph it. So same thing. You want the cosine. It's a cosine. So you get 0 pi over 2, pi, 3 pi over 2, and 2 pi. So you have, what do you have? You have a 4x plus 3 pi. 4x plus 3 pi. You let it equal 0. When it is 0, you solve for it, you get x is a negative 3 pi over 4. Negative 3 pi over 4. Then the corresponding cosine is 1. You see, corresponding cosine is 1. 1 times 2 is 2, plus 1 is 3. So y value is equal to 3. What is this point? This point is exactly this here. Okay, then you let 4x plus 3 pi equal to pi over 2. You solve it, you get negative, or what's this? It's negative 5 pi over 8. Negative 5 pi over 8. Cosine of pi over 2. Cosine pi over 2. When you evaluate the cosine, you have to evaluate this quantity because the whole internal stuff is equal to pi over 2 or 0. So cosine pi over 2 is 0. So times 2 is 0. Plus 1 is 1. So y is 1. So what is this point? This point is here. Let's choose a P1 and P2. This is P1 and P2. And you continue this. You continue this. 4x plus 3 pi is equal to pi. Then x is equal to negative pi over 2. Negative pi over 2, you get negative 1. Cosine negative pi over 2 is negative, cosine pi is negative 1. Negative 1 times 2 is negative 2, plus 1, so y equal to negative 1. This is P3. If you get P3, it is this point. P1, P2, P3. And you continue this. 3 pi over 2. Then x is negative 3 pi over 8. Then y is equal to, here is 0. This part is 0. So the first term is 0 plus 1 is 1. And P4. This point is P4. And when you get the 2 pi, then x is a negative pi over 4. And y is equal to 3 again. So technically, we didn't draw this part. We draw the previous part. So this is P5. P5 is here. You can use this method. You can use this one. Either works. For the cosine, usually we consider 0 to 2 pi. Or you can consider the other method, the other way. We only care if you cover the whole period or not. I mean, at least for me. Okay, so this is the curve graphing. So for curve graphing, you see here we have some fixed steps. Step 1, we consider period. Step 2, we consider the phase shift. Step 3, we consider amplitude. Step 4, if it has a plus a constant or minus constant, you shift vertically upward or downward. Okay, so that's the fixed idea. This is one way to demonstrate to graph the sine function. There's another way. Sometimes we have a graph, we want to determine its function. So we have graph, we want to know the function. So how do we do this problem? So check here. Assume this is A, this is negative A sine x. Let's just consider the simplest stuff. Assume we have this, we just stretch it along the y direction. And then from the graph, how do we know what is the value of A? Or maybe this, you plus some number, this is A. And if we shift it vertically, this one. For example, we have this. This is symmetric, we know what is A. A is this point. But if we have something like this, y is equal to A sine x plus B. We already shifted. Then what is A? A, geometrically, A is 1/2 the top point minus the bottom point. I mean the y coordinate, y, top bottom is about y. So here you have a top point, you check the x, you check the y coordinate. Here you have the bottom point, you check the y coordinate. This difference is twice of A. See here, this is A, here's negative A, then the difference is 2A, it's twice of A. So you use the y coordinate of the top point to subtract the y coordinate of the bottom point, you will get A. And divide by 2, you will get A. So for example, if we see that the graph is like this, and in the system it says this part is 30, this part is 75, then, and we assume this is a trig function, a sine function or cosine function, then A is 1/2 75 minus 30 is 45/2. Okay, so A is always the half of the top point minus the bottom point, y coordinate. Okay, so that's the top and the bottom. And what is this B? What is this B? The B is, you see, B is the middle point. It's exactly between those two top and bottom. Then B is the average or the midpoint of the top and bottom. So B is the top point plus the bottom point divided by 2. So this vertical shift is the average of top and bottom point. The amplitude is the difference of top and the bottom and divided by 2. Okay, so from here we know that the B is 1/2 75 plus 30 is 1/2 105. So this is 105 divided by 2. Don't forget divided by 2. You add them together and you divide it by 2. Okay, so this is the amplitude, the vertical shift and amplitude. Okay, those two formulas are very important. Vertical shift and amplitude. How do we read it from the graph directly once it is moved? Next, How do I know the omega? Remember the period t is 2 pi over omega. Then when you get period, when you find a complete period, then omega, this is a period, then omega is 2 pi over period. You switch omega to the left and the period to the bottom. So this is a way to find the omega, the coefficient. For example, if we see the graph is like this, we just find this. Assume this point is 12. This is 6. So the period is 12. Period is 12, then omega is 2 pi over 12 is pi over 6. Okay, so omega is pi over 6. The other thing, what is the shift? What is the shift? It depends on what function you choose. Let's assume we always use a sine function to approximate the graph. Then this one. The shift is the following. Let me find the graph first. Higher. The graph is like this. The graph is like this. Okay, so what's this? We first have the period, then the period divides the interval into 4 parts. You see here, whenever I have a period, you have 4 parts. 1, 2, 3, and 4. 1, 2, 3, 4. Okay, so then this y is equal to, assume we have some amplitude and we have some sine, and from this 12 we know it's a pi over 6, and then you have minus some let's put it 5 here, and plus a b, plus a value b. And from this part you see what is a shift. This well, I must label them carefully. Let me try to get the label. I need the label. The label is no, label is here. This is 12. Let me first label them and then we explain why we have such a shift. 6. Hold on. What is sorry. Let me get a better graph. We need to read the graph, so the graph should be more precise. So we have 25, 50, 75, 25, 50, 75, and we have value 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. This is 12. 13. Let's put 13. This is 12. 1, 2, 3, 4, 5, 6. This is 6. Okay, and then we have the label. So 1, 2, 3, 4, 5, 6, 7, 8, 7 should be here, 6 is here. Move it a little bit left. 8, 9, 10, 11, and 12. Okay, so okay, so this is the graph, the sketch of the graph. Okay, so without a shift, what is the graph without a shift? Without a shift, it looks like this. The sine. Something like this, okay? Without, so it's the highest point should be at 3. Without a shift, the highest point should be at 3. It should be here, was here, and now it moves to 7. So that's why I have to sketch this graph again. So you carefully read the paper, read the graph. You draw the graph without shift, and you compare it with the graph provided, and you find the maximum point. The maximum point was at 3, but now it's at 7. So it's moved to the right 4 unit. This is 4 unit. So this part, it becomes -4. Remember that phi is positive, move to the right, move to the negative. Phi is negative, move to the negative. Phi is positive, move to the positive. Phi is negative, move to negative. So here it becomes sine pi over 6 times x minus 4. Okay, so you first sketch the graph in the standard way. I mean, I don't care about A and B. A and B, they are about the lift and the period we already discussed. And then you notice that this top point is moved from 3 to 4. So it moved positively 4 unit minus 4. Okay, so that's the idea. Okay, so this is the discussion of section 7.8. In the section 7.8, we have two things. One, you have a function, you graph it. Two, you have a graph, you make a function. And to make a function, there is the steps. So on page 589, there are steps, 4 steps to determine amplitude, vertical shift, to determine omega, and determine the phase shift. So you have to do the exercise, and then you can see the property. Okay, so let me see if I have some examples, proper example. The proper example is something like this. If you cannot, so far we don't have the graph, but we have the following thing. For example, in problem 15 in exercise, assume we know that amplitude is 2, period is pi, and phase shift is 1/2, and write the equation, write the sine equation. Or sine function, not equation, sine function. The sine function is going to be amplitude is 2, sine, period is pi, period is 2 pi over omega. It is equal to pi, so omega is 2. Phase shift is 1/2, x minus 1/2. So that's a formula. Okay, see, amplitude 2, period will help us to find out omega, And the phase shift, just be careful. Phase shift, you must put parentheses here. This number 2, this coefficient is for this difference. It's not just for x. 2 times x minus 1/2. So that's why after you break it, you get a minus 1. Okay? So this is a one possible sine function, not a z. We should say a. Why? Because the other one is also a sine function with this property. You see, amplitude is 2. You can get a positive 2. You can also get a negative 2. And the period, of course, period will uniquely give us this number 2. Phase shift 1/2 is also this one. So this number and this number are fixed, but this amplitude may change, maybe positive or negative. So that's why for this kind of a problem, we only need one sign equation, and that's enough. We don't need all the expressions. There's no all. Okay? Just one is enough. You can put positive 2 or negative 2. Okay, so do your exercise and do your practice exam. I will send you the answer key today, and you compare your answer with the answer key. If you don't understand the steps, ask me. Thank you very much. We'll stop here today.